So let's revise parabola now. So the first thing that we need to understand is what the definition of a conic is. We consider a point P and a point S along with a line which is called our directrix. This point is called our focus. We consider a line PS and the perpendicular distance which is PM from this point to this line M. The ratio of PS to PM is what defines eccentricity. If eccentricity is 0, then it's a circle, 1 parabola, less than 1 ellipse, greater than 1 hyperbola. This is a general equation of a conic, and if delta is equal to 0, so how to remember what delta is? An honest girl having boyfriend goes for college. If this is equal to 0, then it's a pair of straight lines. But if it's not equal to 0, then it can be any of these four conics. If h is equals to 0, meaning there is no xy term, and a is equal to b, then it's a circle. If h square equals to ab and e equals to 1, then it's a parabola. If h square less than ab, e less than 1, then it's an ellipse. If h square greater than ab and e greater than 1, then it's a hyperbola. Now let's look at a parabola general equation. If y square equals to 4x, this is the diagram of the parabola that we actually end up getting. Now, this is our, this is our focus. This is our directrix that we defined earlier. Any point that lies on this conic is equidistant to this point, which is our focus, or this line, which is our directrix. Right. So this axis that bisects the parabola, so it's symmetric. The parabola is symmetric about this axis. This is called our axis of parabola. And this tangent at vertex, it's very self-explanatory. But yeah, this line here is called our tangent at vertex. Any chord which passes through focus is called a focal chord. But if that focal chord is perpendicular to the axis of parabola, then it's called a latus rectum, and the length is 4a. This is the coordinates of the latus rectum a comma 2a, a comma minus 2a. If there's a chord which is not necessarily passing through focus but is perpendicular to the axis of parabola, it's called double ordinate. Only up until here it's called an ordinate. A parametric point for a parabola is going to be 80 square comma 280. This is for y square equals to 4ax. But there are different orientations. There's y square equals to 4ax, there's x square equals to 4ay, there's x square equals to minus 4ay, and there's y square equals to minus 4ax. So depending on that, you should change the parametric as well. So this is a parabola equation that I'm considering. Now basically we can consider this parabola equation as if it's a parabola that's been shifted from a point where its vertex was at origin to a point where its vertex is at 1 comma 2 now, right? So all the lengths like latus rectum length, the a value, all of these doesn't change. What you can do if you have trouble finding vertex, focus, directrix, all these things for a parabola like this is assume that it's equal to capital X. Assume that whatever is in here is equal to capital Y. Now you have a standard parabola which is capital X square equals to minus 12y. You can just write the coordinates for capital X square equals to minus 12y, and wherever you are writing capital X, later substitute it with x minus 1. So I'm just going to write vertex and maybe parametric coordinates as well, and we'll see how it goes. So here for a normal parabola which has x square equals to minus 12y, we write the vertex to be 0 comma 0, and we write the parametric coordinates to be 280 comma minus 80 square. Here you're just going to replace capital X. So we wrote capital X equals to 0, right? Just replace it with x minus 1 equals to 0 and x equals to 1. So that means that the vertex, and you do the same for capital Y, you will get the vertex to be 1 comma 2. The same for parametric coordinates, we wrote that capital X equals to 280. So x minus 1 equals to 280, which means x equals to 280 plus 1. These are the actual parametric coordinates for the parabola that has been given to us, right? Chord of a parabola, basically line segment joining any 2 points that are on the curve. Focal length. So length of any point that's on the parabola to the focus is our focal length. But do remember that sometimes, because it's a parabola, this point is equidistant to the parabola and the line. So sometimes it can be better to just drop a perpendicular onto the directrix and find it out that way. Focal chord. So any chord that passes through focus is going to be your focal chord. But if we assume that one end has a parametric coordinate 80 square, 281, and the other end has a parametric coordinate 82 square, 282, then T1 into T2 is going to be -1. So you can replace this, and write A upon T1 square minus 2A upon T1. Using these two coordinates itself, you can find the focal length formula, which is going to be A into T plus 1 by T whole square. Or if we assume that the angle that the positive x-axis makes with this line segment is theta, then the length of focal chord is 4A cosecant square theta. Now let's look at a JMA 2019 PYQ. One end of a focal chord y square equals to 16x is at 1,4, then length of focal chord. So we have a parabola y square equals to 16x and one end is 1,4. So basically we're going to try to find the value of t, which is going to come out to be 1 by 2. And using the formula, you can just find the length of focal chord or just find the other end and use distance formula. Position of a point with respect to a parabola. So it's the same as what we learnt in circle. If S11 is greater than 0, point lies outside, equal to 0 on the parabola, less than 0 inside the parabola. Line with respect to parabola. So you're just going to solve the line and curve like we talked about in circles. By the way, if you haven't watched that video, it's linked in the description. Solve the quadratic equation. It's going to be either in terms of x or y. If the discriminant is greater than 0, then it's going to be a secant, equal to 0 tangent, less than 0 outside the parabola. Equation of a tangent. So general equation of a tangent you usually write as S1 equals to 0, or this is the parametric equation of a tangent for a parabola y square equals to 4ax. Yt is equals to x plus at, or slope form y equals to mx plus a by m, where c is a by m. So this is the condition for tangency. Now we're going to learn the conditions for tangency, equation of tangent, point of contact for all 4 different types of parabola. So y square equals to 4ax, point of contact is going to be a by m square, 2a by m. Y equals to mx plus a by m is going to be equation of tangent. Condition of tangent is c equals a by m. Now y square equals to minus 4ax. Wherever you see a, you're just going to replace it with minus a. It's the same thing. X square equals to 4ay. Again, something you need to remember, 2am, am square is going to be our point of contact. Now equation of tangent is y equals to mx minus am square. C is minus am square. The same thing, x square equals to minus 4ay. Replace a, wherever you see a, replace it with minus a. You're gonna get all the 3 points that we talked about. Point of intersection of tangents. Now let's say there is a point who has a parametric coordinate t1, another point with a parametric coordinate t2, and I drew 2 tangents at both the points. They intersect at another particular point. The coordinates of that particular point can be defined as, first you're going to take the GM of both the x coordinates, geometric mean. So a square, t1 square, t2 square, which is going to be a, t1, t2, and the arithmetic mean of the y coordinates, which is going to be a into t1 plus t2, which is the point. Point of intersection of tangents at the extremities of focal chord lie on the directrix. So if I drew a tangent from 2 tangents from both extremities of a focal chord, they not only intersect at the directrix, but they also make a right angle. So we defined director circle in the last video, and we defined it as a point from which perpendicular tangents can be drawn onto the conic. This is the director circle. The directrix is the director circle for a parabola. Moving on, pair of tangents formula is the same, s1 square is equals to s into s11. Chord of contact is s1 equals to 0. If midpoint is given, you can write the equation of a chord as s1 equals to s11. Equation of normal, so this is the parametric for y square equals to 4ax, obviously. This is the slope form. Now here just remember one of these, and to write the other you're just going to replace t with minus m or m with minus t. I recommend you learn the slope form. Now again, moving on to all 4 types of parabolas and point of contact, equation of normal, condition of normal. By the way, this table is from JEE Brief Vora classes. The playlist for that is in the description. Let's look at the first conic, y square equals to 4ax. Point of contact is am square comma minus 2am. Equation of normal is y equals to mx minus 2am minus am cube. Condition of normal, you're just going to take this little part, and that's going to be the condition of normal. Y square equals to minus 4ax, basically you're gonna multiply this by minus, like just replace a with minus a. So here you have minus am square minus 2am was there, so you have 2am now, the same. Now x square equals to 4ay, you have this as your point of contact, this as your equation of normal, this as condition. Again replace a with minus a and you get the same for x square equals to minus 4ay. When the conic itself has minus, you're going to do the multiplication of minus as well. If normal at point, so basically let's say I have this parabola at parametric coordinate t1. I drew a normal. Now it intersected the parabola again at a parametric coordinate t2. Now the relation between t2 and t1 can be given as follows. t2 is minus t1 minus 2 by t1. Co-normal. So from any point h comma k which lies inside the parabola, 3 normals can be drawn on the curve. And like I said, this is the equation for a parabola normal. How do you find all 3 equations? Is basically you're given the point h comma k, you're going to satisfy this equation with h comma k, and you'll get a cubic equation that's going to be in terms of m. Solve it to get 3 solutions. But if you notice here, there's no term of m square, which means the sum of all 3 slopes is going to be 0. And this whole thing is only valid, like you can draw 3 normals only if h is greater than 2a, h being the x coordinate. Now the centroid of feet of 3 normals lies on the axis of parabola. So basically I have a point that lies inside the curve, not on the axis necessarily, inside the curve. I drew 3 normals. Now if I were to, so this is the point of contact of normal number 1, point of contact of normal number 2, point of contact of normal number 3. Sorry. Now you're going to make a triangle out of this. The centroid is going to lie on the axis of parabola, and this is going to be the coordinate of the centroid, which is 2h minus 4a upon 3 comma 0. Diameter of the parabola, y equals to 2a by m. Diameter is basically, if you take a conic, draw a bunch of parallel chords, the midpoint, the locus of the midpoint is going to be the diameter. Properties of parabola, so now we're going to go through some properties. Let's say this is a focal chord, well, not necessarily, but let's say this is a point A and I join it with the focus. Assuming this as the diameter, I draw a circle that touches the tangent at vertex. This is not an accurate diagram, I drew it very bad, but yeah, you get the gist. Now if I assume the entire focal chord as the diameter, not the radius, this circle is going to touch the directrix. Again, a bad diagram, excuse me. So now if I have a tangent, this is a tangent that I drew onto this conic. If I were to draw a perpendicular onto this tangent, it's going to intersect the tangent at vertex and it's going to make a right angle. That's all I wanted to say. No, wait, I have another thing to say. Let's say I have a parabola. Now I have 3 points that are on this parabola, A, B and C. Now A, B and C can be joined to make a triangle, and let's say the area of this triangle is A1. Now we're going to draw 3 tangents at 3 of these points, like at A, at B, at C. I am very bad at drawing, so excuse me. Actually, yeah. So this is the triangle that's been made by their tangents. The area of this can be assumed to be A2. Now A1 is going to be twice A2. That's all I wanted to say. Thank you for watching.